Hello everyone, so today we're going to go over how to calculate z-scores by hand. Here I already have an example in front of you with the z-score calculation. At the top here, this is where we have the value of x, the mean, which you might see other scientific notation where it looks like a U with a long side on the left. The standard deviation, you might see something like that at the bottom, where it's x minus the mean over the standard deviation. So for our example here, we have a class of 63 students. They took an exam. The average on the exam is a 78 with a standard deviation of 7. And we know Pamela got an 89 on that exam. We're interested in what is the probability of scoring higher than Pamela on the exam. So we need to look up her z-score and look at what value under the normal distribution, what percentage is to the left. From that, we can take 1 minus that to get what area is left over. And that gives us who scored higher, so the right side. So if we come back to a z table itself, we're interested in what's going on here on the right side. So above, it always gives us to the left. We'll come back to this once we get the z-score calculated. So bring up the whiteboard. All right, so let's calculate Pamela's z-score. So we have at the top 89 minus 78 in the numerator divided by 7. So here we have z is equal to 11 over 7. So our z-score is, put it in the calculator, 1.57. So we already see that it's positive. So if we're making sense of the normal distribution, and we see something like this, to where we have 0 here, 1 and 2 and 3, 2 and 3. So we know this is plus 1, minus 1. These are standard deviations. Minus 2, minus 3, plus 2, plus 3. So at this point, we already know that Pam's score is 1.57 standard deviations from the mean. So it's about, here I'll change the color, it's somewhere about in here. So we know that she scored better than this area down here. What we want to find out is what percent of the area is this, and what's the probability that someone's got higher, or what's the score higher than this. We're trying to see the difference of that. So if we come back and go to our z table, we're going to look up 1.57. So it's a positive value. So we start on the left and we see 1.5, and we go over to where it's 7. So we have 1.57. So we have 94.18. So we got 94.18. Now if we move this over to a percentile, we would just take the decimal place and move it over to here. So we have 94.18%. So she scored higher than 94% of the class. That means if you took 100 and then subtracted the 94, you get about the probability of scoring higher than Pamela on this exam was about 6%. And if we look at the class size, so we know there's 6%, and we can take 6% of 63, and we multiply that, and we know that it's about 3 to 4 students likely scored higher than Pamela. So this is a quick way to understand z-scores and where Pamela's score fell and the probability of scoring higher than Pamela. Now, what if we were interested then in trying to find out what score you needed on this exam to fall within the top 25%? So we're now interested in what value, what score did you need? So what score is needed to be in the top 25% of the class. So at this point, we already know that we have the top 25%. So we're interested in finding what z-score would give you the closest to. Remember, when you look up a z-score, it's going to give you everything to the left. So it would give you everything this way. So we're interested in finding the closest value to 0.75, because to the right of that would give us the 25% we're interested in finding. So if we look up on the z table, we're going to find the value as close as we can to 0.75. So if we get it here to 0.7, let's see. If we come over here, there we go. So 0.67 gives us probably the closest we can get to it. Yep. So 0.67. Let's come back over here. Move this down. So our z-score that we have is 0.67. That gave us our closest value to getting to 0.75 as we could. Obviously, you saw there wasn't an exact value, so we had to go with the closest one to it. So if we look at that now, we can plug it back into an equation and solve for the value itself. So with that, let's pull up the formula again. So we have up here, this time we know what the z is, and we need to solve for the value of x. So we have 0.67 would be equal to the numerator x minus the mean is still 78 over the standard deviation of 7. So the first step here would be then to get rid of the denominator. So we want to multiply both sides by 7. These cancel out, and then we multiply over here. So let's do that. 7 times 0.67 gives us 4.69. We now have x minus 78. Now the next order of operation would be to add 78 to each side. That cancels out, plus 78. So here we get x would then be equal to 82.69. So to get in the top 25% of the class itself on the exam, you'd need a score of about an 82 to 83 if you round up to 83. That would let you get to be in the top 25, the top quarter of the class. The key part here is to remember, since we're interested in the top 25%, that's going to be to the right of the actual z-score. So we have to keep in mind that we have to look up the value that gives us the percentage to the left, and that would be the 0.75. So that's where we got the 0.067, and then use that to solve backwards to find what score you needed on the exam to get into the top 25%. So that's a quick example of how to calculate a z-score, then how to solve backwards if you're given another way of looking at it within the top percentile and working backwards from that. The same would go if you were looking at negative values. You would still do the similar process. The values are still to the left. You just have to keep in mind that if you're looking for the top, the greater than, higher than, you have to remember to subtract that from 1. If you're looking at less than, you can always go and look at it that way because that's what gives it to you within the z-table itself when you look at it. So if there's questions, please feel free to reach out. If not, enjoy. Happy practicing.